guys, how are you all doing? Welcome back to my YouTube channel Study Don't Worry, and in today's video we are going to study the simple and easy chapter Force and Pressure, and the topics covered are force, turning effect of force, pressure, thrust, liquid pressure and gas pressure. So let's start now without any delay. First, let's understand force and its units. To understand force, we'll take a simple example. Take a book on your table. Now push it or pull the book. Now you see there is a change in rest or motion. First the book was in rest, and now when you pushed it or pulled it, it is in motion. Take a rubber band and pull it. Now you see that there is a change in shape and size. So this is what is force. A push or pull acting on a body which may result in change in state, rest, motion, shape and size, etc. is nothing but force. And it is also very important to understand that force is a vector quantity, and to completely specify force, we need to be specifying its direction and magnitude. And it is also important to understand that force, the SI unit of force is Newton. And force can be measured by spring balance. It is an instrument which is used to measure the force. The spelling is springbalance. So this was the simple topic of force and its units. Now let's go ahead. Turning effect of force. Now let's also understand turning effect of force with a simple example. When you take a normal table and when you push it, what happens? The direction which you push, it will go in that direction. For example, you are pushing the direction in front in a forward direction. The box will also go in a forward direction. Now go to any door of your house and now push the door in push the handle in a forward direction. But here the door will not go in a forward direction. It will move around the door hinge. Why will this happen? This will happen because of the turning effect of force. It is the turning effect of force is the force in which body moves around a pivoted point. And here pivoted point means a object which is fixed at an fixed position. Here in this picture you can see here are the hinges. So here the hinges are attached to the wall. So this is nothing but the pivoted points. So in this example, turning effect of force, we see when you push the door with the help of the handle, the door will move around the hinge. That is the pivoted point because of the turning effect of force. And to define turning effect of force, it is the force in which the body moves around a pivoted point. So this was the very simple topic of turning effect of force. And with this turning effect of force completed, we come to another most important topic, that is moment of force. Moment of force is the product of magnitude of force and perpendicular distance between the point of application and pivoted point. What is magnitude of force? The amount of force being applied to any object which results in the effect of force is called as magnitude of force. The amount of force being applied to an object. And the perpendicular distance between pivoted point and point of application. So here let's go back to the door example. When you open the door, what happens is it moves around the pivoted point, that is hinge. And now in that handle part, you see that have you ever thought why is the handle always the maximum distance from the hinge, that is the pivoted point? And why can't the handle be near the hinge, or why can't it be in the middle of the door? Why? So this is the answer of that question, because more is the distance between the point of application of force and pivoted point, more will be the moment of force. So the handle of the door are always given maximum distance from the hinge, so that will be able to easily open the door. If you keep the handle in middle of the door, it will be very tough to open the door. And if you keep the handle near the hinge, then it will be impossible to open the door. So the handles will be placed at a maximum distance from the point of application of force and pivoted point. And moment of force is the product of magnitude of force and perpendicular distance between the point of application of force and pivoted point. So point of application of force and pivoted point, that is the distance and into magnitude of force, and both are proportional to moment of force. That is, more the magnitude of force, more is the moment of force, more is the distance, more is the moment of force. So to increase the moment of force, we need to be increasing either of the quantities, or we can increase both. So this was the simple topic of moment of force, and the SI unit of moment of force is Newton meter. Yes, it is Newton meter, because the SI unit of force is Newton and distance is meter. And here the two important things are force and distance. So they have taken the SI unit as Newton meter. So let's go ahead to the next topic, pressure. Now let's also understand pressure with an example. Now I said you that when the door handle, when you put pressure on the handle, the door moves around the hinge. So that the door moving around the hinge is nothing but the pressure. So basically what pressure is, it is the effect of the measure of the force. So on any object, when you apply any kind of force or in any direction, there will always be an effect, and that effect is nothing but pressure. It is the measure of effect of the force, and you can also define it as the normal force acting on the unit area of surface. And pressure is all, the formula to find out pressure is force divided by area of contact, and the SI unit of force is Pascal. Yes, it is Pascal. And we should remember that pressure is the measure of effect of force. Next, we've completed the pressure topic. Now let's go to the topic of thrust. It is the normal force acting perpendicular to the surface. For example, a pin on a pin, when you put it on a bulletin board, and the SI unit of thrust is Newton. Now the major question that arises is, what is the difference between thrust and a pressure? So thrust is the total force. It is complete, the whole force that is being applied, that is the total force of acting perpendicular to the surface, that is thrust. Whereas what is pressure? In pressure, it is the thrust that is acting per unit area. And even another important thing is that thrust is not dependent on the area of contact. Thrust doesn't depend on the area of contact. It can be anything. It doesn't matter. It doesn't change the thrust value. But pressure is always dependent on the area of contact, because it is not the total force. And the SI unit of thrust is Newton, whereas the pressure, SI unit of pressure is Pascal. So these are the three differences which differentiate thrust and pressure. That is, thrust is the total force acting perpendicular to the surface, whereas pressure is the thrust acting per unit area. Thrust does not depend on area of contact, but pressure depends on area of contact. SI unit of thrust is Newton, whereas the SI unit of pressure is Pascal. So here we came to an end of even the thrust topic. Now let's go to the next topic, that is pressure exerted by liquid. Where by the word only we can understand that it is nothing but the pressure exerted by the liquid is called as liquid pressure. And another important thing here is the topic of lateral pressure. So the pressure exerted by the liquid also exerts pressure on the walls and the bases. So when you put any liquid in the container, for example, oil, water, anything. So when you put liquid in it, it exerts pressure on the walls, that is the surroundings, and even the base of the container. And this pressure is called as lateral pressure. And let's come to the topic of factors affecting liquid pressure. There are two factors affecting the liquid pressure. They are height of the liquid column and density of the liquid. Height of the liquid column. This is proportional to, it's directly proportional to pressure exerted by liquid. That is, more is the height of the liquid column, more will be the pressure exerted by the liquid. And next is density of the liquid. This is also directly proportional to the it's directly proportional to the liquid pressure. More is the density of the liquid, more is the pressure exerted by the liquids. Now, let's go through some very important experiments. This is the experiment number 1. And here the aim of the experiment is to show that liquid exerts pressure and the pressure increases with increase in height of the liquid column. So here you see in case 1, you take a tube which is open on both the sides, and at one side you put a balloon, an inflated balloon, and now you put water in the test tube. And now when you put water, what you see? Little water, not more than half, less than half. And what you see when you put water in that, the balloon bulges a little. Why does the balloon bulges? Because of the pressure exerted by the liquid. The pressure exerts liquid on the balloon, so the balloon bulges. So from this we can clearly understand that liquid exerts pressure. And in case number 2, what happens? You pour more than half of the water. 3/4 of the test tube should be filled with water. Now what you see is the balloon bulges even more than the case 1. Why this happens? Because the pressure of the liquid increases with the increase in height of the liquid column. That is this is a factor which affects liquid pressure. So when there is more height of the liquid column, more the pressure. So here the balloon bulges a little more. Now experiment number 2. This is to show that liquid exerts a lateral pressure, that is a pressure on the walls and the bases. So now what happens? Take a balloon, take test tube which is open at one end, and it has a spout. That's a spout is nothing but a small opening at any part. Let's keep the spout at somewhat like at the down part here. Now you attach a balloon, that is the opening of the balloon at the spout. You see the balloon will have no difference. Now put some water, more than half of the water. Now see what happens. The balloon inflates. Why does this happen? Because the liquid exerts pressure on the wall, and here the spout is there on the wall, and through the spout the pressure goes to the balloon, and that results in the balloon being expelled, that is being inflated. So this was the experiment number 2. Next, let's go to the third experiment, which is very important. Here, this aim of the experiment is to show that pressure exerted by liquids increases with a pressure with increase in depth. So now you take a test tube with 3 spouts. One spout at the top, second spout number 2 at the middle, and spout number 3 at the bottom. Now pour fill the beaker completely with water. Fill it completely with the water. Now at the spout you need to be attaching. So before putting the water, you need to be attaching sellotapes to that, so that the water will not be expelled out at the starting only. Now when you fill the water completely, now immediately remove all the 3 together, all the 3 sellotapes for all the 3 spouts together, and you'll see what happens. From spout number 1, that is the mouse, my mouse is showing here. So what happens is, when you remove the sellotape, the water will form at a very, very, very minimum distance. So when you open the sellotape at spout number 1, the water will form at a very minimum distance. And in spout number 2, when you open, what happens is the water falls at a maximum little more distance than the spout number 1. So here you see the difference. In spout number 2, it is more than spout number 1. And when you open the spout number 3, what happens here is the water where the water falls is the maximum distance from all the 3 spouts. So see here in the diagram, first spout it falls very near. Second, it will go a little more than spout number 1, and spout number 3, that is the last spout given at a very high depth, it reaches the maximum distance in all the 3 spouts. Why does this happen? This happens because of the law that liquid pressure increases with increase in depth. So from spout number 1, there's no depth only, so it falls at a very minimum distance. Spout number 2, there's a little depth, so it will go more than spout number 1. But spout number 3, it is at the greater It is very deep. So here the distance will be maximum. So the water will be reaching a maximum distance. So this was an important topic. Now let's go to the next topic, that is manometer. A manometer. So what is manometer? A manometer is a simple device which is used to measure pressure exerted by a liquid. So it is a U-shaped device filled with some liquid. Most probably it will be water or mercury, because mercury has a high density. So it will be most probably liquid or mercury. One end of the tube, so one end of the tube will be left open to the air, and other end will be connected to a thistle funnel. That thistle funnel will be connected to a rubber membrane, and that rubber membrane will contain nothing but the liquid whose pressure needs to be measured. And now I'm placing that, you see there will be a difference in the U-shaped thing. You'll see a difference in both the liquids. You'll see a difference in the readings. So that difference is nothing but the liquid pressure. So manometer is a simple device, a U-shaped device. So one end will be exposed free and one is connected to a thistle funnel which has the liquid whose pressure needs to be measured. And as soon as you connect it to a thistle funnel, there will be a difference in the pressure, and the difference is only the pressure exerted by the liquid. So let's go to the next topic. Gas pressure and atmospheric pressure. Now, pressure exerted by gases, this is a very simple definition. The pressure exerted by the gas is defined as the gas pressure. Now, atmospheric pressure, the pressure exerted by atmosphere is called as atmospheric. Yes, even atmosphere also exerts pressure, and it exerts pressure up to 300 km from the sea level. Sea level is the normal level of our earth land. So the atmosphere exerts pressure on up to 300 kilometers from the sea level. And you know that then one of the example I said that liquid pressure increases with increase in depth. Here is also the same. With an increase in depth that is near us, even the pressure will also be increased. And the atmospheric pressure at sea level is 1,01,325 Newton meter. That is what moment of force SI unit, Newton meter. So the atmospheric pressure at sea level is 1,01,325, or you can, for in order of kilopascal, you can tell it as 100 kilopascal. So now this was the simple topic of atmospheric pressure, and we'll conduct one experiment which will explain us about the pressure exerted by the gas. Now this first, what you need to be taking is can filled with water, not necessarily need to be full, it can be half. Place it on a wire gauge, and the wire gauge should be placed on a tripod stand. Put a Bunsen burner under the tripod stand and on the tripod stand, and let the water heat. Now the water will be fully heated. Now when you off the Bunsen burner, immediately close the can with its closing cap. So you should immediately close it. And now take some very cold water, and what you need to be doing, you need to be putting a little, and you need to put the water on the closed can, and this is what will happen. A very weird thing will happen, that is the can will be completely crushed. Why will this happen? Because of atmospheric pressure. So when you heat it, all the gas all the air in it will be heated, and hot air is lighter and it floats up. And when it floats up, you off the gas and you cover it, so no air can enter it. So inside there is no gas left. So there's a very, very, very low pressure created. And when you put cold water, there'll be a different pressure. Inside will be completely low pressure, and outside will be high pressure. That is atmospheric pressure. So when you put the cold water, with very low pressure and high pressure being hitting each other, it will result in the crushing of can. So this is a very important thing, that is whenever a low pressure or high pressure crushes, it results in any big, like what happened in the can, it will get crushed or something, it will result. So that is what is mountainous. So I'll tell you an example of mountainous. Mountainous will always be suffering nose bleeding. Why will this happen? You know, when you go to the mountain part, Himalaya and all that, it will be very, very, very cold. And outside there will be a very low pressure. And inside your body, it will be high pressure. Outside, because your normal body will be set to high pressure, whereas outside it will be low pressure. So when our nose, in this case, our nose will also be having high pressure, and outside is clearly low pressure. So when these both crashes, there'll be and results in no blood bleeding from our nose. And another example is astronauts will be wearing specialized suits to go to space. Why so? Because in space it is the least pressure we can ever find in anywhere. So we have a very, very, very low pressure, whereas in your body it will be on high pressure. So when your body pressure and your low outside the body pressure, that is high pressure, and the outside low pressure combined, it is so low pressure that may even result in blasting of the whole body only. So there were specialized suits to create even or high pressure or low pressure. So they always wear specialized suits. So guys, this was the simple topic of force and pressure. Hope you understood this whole concept clearly. Please subscribe, share and like to our channel. Comment any chapters to be explained. Thank you and have a nice day ahead.